Good afternoon and welcome to the Q&A session 5 from the playlist of waves. The topic is the calculation of speed of sound in a gaseous medium. And based on this topic, I have one question for this session which is written here on this board. So the question here is, the speed of sound in oxygen is 460 meter per second at a certain temperature. Speed of sound in helium at the same temperature will be, assuming that both the gases are ideal. So we have been given here 4 options and we have to find the correct one. So in the previous session, we have seen that the speed of the sound in a gaseous medium, that is V, is equal to under root gamma R T upon M, where M is the molar mass, gamma is equal to Cp upon Cv, R is the universal gas constant and T is the absolute temperature. So here the temperature in both the cases is the same, R is a constant. Now here we have to basically find the value of gamma and the molar mass in the case of oxygen and in the case of helium. Now gamma is also equal to 1 plus 2 by F, where F is the degree of freedom. Now the degree of freedom for a diatomic gas, oxygen is a diatomic gas, this is equal to 5, and the degree of freedom for a monatomic gas, this is equal to 3. So helium is a monatomic gas, so the degree of freedom for the helium will be equal to 3, and for the oxygen, which is a diatomic gas, the degree of freedom will be equal to 5. So the value of gamma for oxygen, this will be equal to 1 plus 2 by 5, so this is equal to 7 by 5. 1 plus 2 by 5. So if I take the LCM, so it will be equal to 7 divided by 5. And similarly, for the helium, the value of gamma will be equal to, if I will be substituting the value of F as 3, so this will be equal to 5 by 3. So this formula is available in the chapter of heat and thermodynamics. So we have found the value of gamma. Now M. M is the molar mass. Now the molar mass is expressed in gram per mole, and this is also equal to the molecular weight in AMU, that is atomic mass unit. So the molar mass for the oxygen will be equal to the molecular weight in gram atomic unit. So the molar mass for oxygen is equal to the molecular weight in atomic mass unit. So the molecular weight in atomic mass unit for the oxygen is equal to 32. So the molar mass will be equal to molar mass in it is the unit of the molar mass is gram per mole. So the molar mass in gram per mole for the oxygen will be equal to 32. And similarly, the molar mass for the helium is equal to 4. So I will be using these values in this formula, that is V is equal to under root gamma RT by M, and then we will be able to find the speed of sound in helium. So the speed of the sound in oxygen, this is equal to gamma is equal to 7 by 5 R. Let us assume that the temperature in both the cases, that in the case of oxygen and helium, is the same, and this is equal to T. And the molar mass in the case of oxygen will be equal to 32, and in the case of helium, this will be equal to, gamma is equal to 5 by 3. The temperature in both the cases is the same as per this question, so this will be equal to 5 by 3 RT divided by the molar mass. So the molar mass for the helium is equal to 4. So I've got here, this is the equation number 1 and this is the equation number 2. So if I divide this equation number 1 by equation number 2, I will be getting another equation. That is velocity of oxygen divided by the velocity of helium. This will be equal to what? This RT and RT will get cancelled out. So finally I will be simply getting the value as under root 7 upon 5 into 32 this will be equal to this 12, but it is 5. This will become equal to 5 RT by 12. So 12 will come in the numerator in this equation and divided by 5. Okay, so that is 7 upon 5 by 32 is divided by 5 divided by 12. So 12 will come in the numerator and 5 will go in the denominator. So here the speed of sound in oxygen is 460. So I will put in here value as 460 divided by the speed of sound in the helium, and this is equal to under root this is 6 and this is divided by 2. This is equal to 6 and this is equal to 116, again 3, and this is 8. So this is equal to 20 and 21 divided by 25 into 8. So the velocity of sound in helium will be equal to this 460 into 5 into under root 8 divided by under root 21. So if I find the value of, so by simplifying this equation, I will be getting the value as this is equal to 6505 approximately 6.05.38 divided by root 21. Now the value of root 21 is equal to 4.58. So this is equal to 6505 divided by 4.58. This is equal to 1420. 1420 meter per second. So the speed of the sound in the helium will be equal to 1420 meter per second, and the correct option here is D. So the most important thing here which we have to use was the formula for the gamma, where gamma is equal to Cp upon C, but this is also equal to 1 plus 2 by F, where F is the degree of freedom. So the degree of freedom for the oxygen, this is a diatomic gas, so the degree of freedom for a diatomic gas is 5. Helium is a monatomic gas, so the degree of freedom is equal to 3 in this case, in the case of helium. So this was an important formula, and so by using this formula and by substituting the value of the molar mass, we were able to find the velocity of sound in helium. So thank you very much for joining this session. In the next session, I will be coming up again with a different type of question from the same topic, that is the speed of sound in the gaseous medium. So till then, have a nice day. Bye.